Hello, today I'm going to be teaching the Hypercolor module, which, as of when I am recording this video, came out yesterday, I believe. And from the manual, it looks like it's very complicated. However, there's a very simple strategy that should get you the answer in under 5 minutes. Now, I will describe what the manual would ask you to do, but for the most part, that's just some background that'll help with some logic and deductions, but it's not really necessary. All you need to do is follow this strategy. Basically, there are two hypercubes, which are these 16 vertices, right? There are two of them, and they are hidden. They are not displayed directly to you. And each vertex of the hypercube has a color channel value of 1 or 0 for each channel. So for instance, it could look like that, it could look like that, or any combination of 1s and 0s. Now, the two cubes will have their two channel values that correspond to the same position. They will be added together. So for instance, in this top one, it would be 1, 1, 2, and the bottom one would be 2, 1, 1. And this would correspond to these base 3 colors, similar to what you have in RGBA, if you have solved that module before. Now, the goal of the module is to identify the one color that does not have any repeats. So there will be one color across both cubes that is only present on one vertex across both. Now the way to do this is to identify colors that uniquely show and guarantee to you that that color is present. And you begin to rule out colors the more you see them, and until you have one color left, and then you simply find that color and click on it. So right here, what we're first going to do is that we're going to look for the bright ones. So the bright ones are the ones in the corners of this left grid and the corners of this right grid. And as you can see, we have these two whites. What does that tell us? Well, it means basically these two have a base 3 color channel value of 222. And the only way to reach this by adding two colors is to add two whites, so 111 and 111. Basically what this means is that we have proof that these whites, two of them are present. And because we have that proof, we can go ahead and rule out white, because our target color is not going to have more than one occurrence. So that was a very easy case. We had a really bright color. However, sometimes you'll need to stretch across several colors. Because the whites show that there are two of the same colors stacked on top of each other. However, if you take a look at these two right here, they are not so bright. They are not any of these 8s that I have pointed out in the corners of the left and right grid. However, what they do show us is that they uniquely identify black in both situations. Now, you'll notice that both of them are very dark, and this is because one of them has a color value of 0, 1, 0, and the other has a value of 1, 0, 0. And the way you can figure this out is, first you identify where on the grid this is. So for this red one, it's all the way at the bottom here. Then, so it's going to be on grid 1, so that's the first digit. It's going to be on the left, so that's a 0 for the second digit. And then it's going to be at the bottom, so that's a 0 for the third digit. And similarly for green, the first digit is a 0 because it's on this grid. The second digit is a 1 because it's in the middle here, horizontally. And then the final digit is a 0 because it is at the bottom. So these two have to come from a stack of two colors, because that's just the way the module is set up. So this green one is going to be a stack of green and black, and this red one is going to be a stack of red and black. And now since we have two vertices that have black present in them, we can go ahead and rule out black because it is not our target color. Another good way to rule out colors is by taking a look at colors that are the same. Now, right here you can see that there's these 3 purples, there's these 2 salmons, and there's these 2 grays. Now, the salmon and the gray, they would be useful for coming in a pair, but unfortunately, they don't tell us definitively if a color is present. So instead I'm going to use the purple, and I'll explain what I mean by that in a little bit. So for these purple ones, you can see on the grid that they correspond to 1, 0, 2, and this can only be an addition of blue plus magenta. So magenta would be red and blue together, and blue is just blue. So because we have 3 of these colors, we can go ahead and rule out both of those colors. Now, if I take a look at this gray, and I want to try and rule out something with the gray, we're going to end up with 1, 1, 1. And this cannot uniquely show an addition, because we could have gotten here by adding these two, we could have gotten there by adding these two, we could have, you know, the list goes on. We could have just done any of these 3. So we can't definitively say that any of these 8 colors are present, and that's not going to be helpful for us. So grays, you can basically completely ignore. Similarly, this salmon color is going to be 2, 1, 1. And again, we find that we could have had several combinations here. We could have had any of these to add up to 2, 1, 1. Now, the tell for this is how many 1s are in the code. So, for example, if you have 2, 2, 0, you know exactly what added that up. It was 2 yellows. If you have 2, 1, 0, then similarly you know that it's going to be red and yellow. But if you have 2, 1, 1, now you have 2 of these 1s, and these show a sort of uncertainty where we can't tell exactly what happened. So, you want to stick to numbers that have 1 or 0 amount of 1s. So, 1 or less. Now, to see what colors these are on the graph, or on the chart, all you need to do is look at the circle on the first grid, the corners of the second grid, and then another circle on the third grid. So anything in the middle for the first grid, anything that's on the plus for the second grid, and anything that's in the middle for the third grid are not going to be helpful in deducing which colors are present. Anyway, once you press on the module, the colors will basically shuffle. What they're actually doing is that each hypercube is performing a 4D rotation. However, that is not necessary to solve the module, and we don't need to care about that. All we need to know is that every color is moving in one direction by one space. And that's all we need to know. So right now we're looking out for 4 colors. We're looking out for R, G, C, and Y. Now, one thing that we can do to heavily speed up the process of finding out what colors identify these is by writing out this sort of chart that I'm going to write. We'll take it one at a time, but the process is overall the same. And in the description, I have a short chart that explains what I'm adding to get these values, but I'll explain it here as well. So for red, we're going to add the secondary that contains it, the other secondary that contains it, then we're going to add black, so there's going to be no change, and we're going to add red, so it's just going to double. Now, on the graph, this is going to correspond to 2, 0, 0, that's this bright red, and I'll put an exclamation mark there to show you why, and I'll explain that later. 1, 0, 0, that's going to be this darker red. We have 201, that's going to be 201, that's this rose, and finally 210 is this orange. Now, this exclamation pointed red, basically what this tells us, to me, is that because there's no 1s, this has to be the addition of 2 reds, which means that 2 red vertices are present, and we can instantly rule out red if we see that. For these other 3, we need to see a combination of 2 of these, at least 2 of these. There can be repeats and stuff, as long as we see 2 of them, in order to rule out the color. Now we're going to repeat this for the next 4. You don't need to do this once you get the colors down, or if you just remember to rule out things with bright colors, it can go a lot faster, but if you are struggling, then this is definitely a good idea to make sure that you're getting those colors right. So green, we're going to add the secondary, the black, and then the double. So 0, 2, 1, that's going to be jade. 1, 2, 0, that's going to be lime. 010 is dark green, and 020 is green, with an exclamation point. Cyan, we add a primary that it contains, the other primary it contains. This time we're going to add white instead of black, and then this time we simply double it. So this is going to be cyan, exclamation point. This is going to be light cyan, which is this color right here, 1, 2, 2. This was the bright cyan. Then 012 is going to be azure. and 021 is going to be jade. And then finally for yellow, same process, add one of each primary, add white, and then add itself. And for 210, that's going to be orange again, 120, that's 120, lime, 221 is cream, and 220 is good old yellow. Alright, now, all we're doing now is looking for any repeats here. So right now I see this dark green, and I see a couple of other greens, so I'm thinking I could rule out green here. But this green is light green, which is the one directly to the right of the center, right here. And that is 121. That is not going to help us because it has 2 1s in its code. However, this lime down here is one of the ones listed in green. So we have one lime, we have one dark green. So we can go ahead and rule out green right now. Now that we've ruled out green, we can just go ahead and delete this entire group because we can save space that way. Now, cyan and yellow. Now, you can go through and check and make sure. However, looking at this, I don't see much red, much cyan, or much yellow. So I'm just going to re-roll until it seems like those colors are very present. There's a bit of cyan up here. Let's see if we can do anything with that. So cyan likes light cyan, then we need jade or azure. But neither of those are present, so we're going to keep rolling. Alright, we have, again, very little of use. Keep re-rolling. Again, nothing much. We do have a lime here that could help us rule out yellow, but I don't see anything else, so we're gonna re-roll. Still nothing. We have another lime here. We have a lime here, and we have a light cyan here. Can we do anything with that? We need a jade or an azure. Again, we don't have those, so we re-roll. Another light cyan, but no jade or azure. We do have a yellow here. Can we do anything with that? We would need... Or this is cream, not yellow, so we need orange or lime. But we don't have either of those. Alright, we've got a lime up there. Let's see, we have a lime here and a cream here. So here's where we can go ahead and rule out yellow. Now normally this doesn't take quite this long, but it can be very finicky. I also think that there might have been a couple times where I missed red, because I was looking mostly out for yellow and cyan. However, if we have red here, we can see that we have dark red here, and we have this rose color here. So that's 2 from our list of reds, so we can go ahead and rule out red as well. Now, we know what our target color is. It's cyan, and all we need to do is find one of the 3 present colors that represent cyan, and click that, and we will be done with the module. So, we've got cyan, light cyan, azure, and jade. The very bright cyan is never going to show up, because that would imply that there are 2 cyans stacked on each other. And that's not the case, because we know that cyan is our target color. Okay, so light cyan's here, and that solves the module. Alright. I'll now do it a couple more times, this time with a little bit less notepad work, because it is rather soloable. I'm going to go ahead and cancel out yellow, because I can see it. Right here, that's the brightest yellow. We also have 2 dark blues, which means I can rule out black and blue, because those are the only 2 that combine to that color. We also have a white here, the brightest white, so we can rule that out as well. This is the brightest green, that's going to rule out green as well. We do have 2 light cyans, those both confirm that there are 2 cyans. And we need red and magenta. Now, red is present in orange, but I don't think I can make any other guesses from here, so I will start to re-roll. Now, if we get... Here's a cool trick if certain conditions are met. Now, if we have red and magenta, when these add up, they add up to something that uniquely identifies red and magenta. So, for instance, if we had red and cyan left, that would be 100 plus 011, and that would add up to gray, and gray does not tell us that red and cyan are in that these 2 are on the module. So it suggests that it's a possibility, but it doesn't confirm it 100%. So because we got red and magenta, which do confirm when they add up that those 2 are present, because again, there's only 1 1 here. Since we have gray is 3 1s, that's not going to work, but red and magenta works perfectly fine. So if we find 201 on the graph, we have 201, and that's this rose color. And what that means is that if we find a rose color, we can just press it right then and there, and we don't really need to rule out the last part. The reason for this is because we know for a fact that one of the two is on that spot. Or one of the two is the target color, and both are present there. So no matter which one is the correct one, that would still have been the correct vertex to press. So we're just gonna reroll until we get rose. It actually doesn't seem like it wants to come out as rose, and that is quite possibly a parity issue, and I'll explain what I mean by that in a moment. This confirms red, but that's it. Oh, okay, so we have 201, or 210 for orange, and 100 for red. Those confirm that red is not the target color, so I wanted to show that strategy, but this generation did not allow me to. And this rose is going to be containing magenta. In fact, this rose, if it decided to show up earlier, I would have just pressed it and we would have been fine, without ruling out red, but it did not. Now, sometimes this won't ever happen, that the last two vertices stack, because sometimes, let's say that you want these two spheres to stack. Let's say that there's red behind this one and black behind this one or something. Now, when this one moves, it moves one away or one towards this one. And when this one moves, it moves also one away or one towards this one. Alternatively, they can move parallel to each other, in which case they would both be moving parallel due to how the hypercube turns out. But basically what this means is that they can only get jumps of 2. So if they're 1 away from each other, they can't go to -1 away from each other. That doesn't work. So they will never land on the same vertex. That's a digression. I will solve this last one. I have basically showed every single strategy that matters, and this should go by very quickly with all of that in mind. So green, we have a really bright one here. Blue, we also have a really bright one there. We have this yellow present here, but I don't know if I can cut that out. We have this lime. Does lime represent yellow? It's represented by 1, 2, 0. And that does confirm yellow for us, so I believe that we can go ahead and cross out yellow. Oops. Because we have these two limes. We have blue twice. Well, actually, we already knew that. So I will move to the next. We're still trying to rule out red, but this cyan here, does it tell us anything? I don't believe it does. So yeah, I will continue. That's a bright yellow, but we already ruled that out. That's a bright red, so we can go ahead and rule that out. We have this dark color here. Oh, that's the bright cyan as well. We're getting very close. We have this dark color here that represents a black, but nothing else, so we cannot rule anything out. Okay, still doesn't seem to be anything. Right now we're looking for magenta, white, and black. Actually, this and this do represent white, because you have 2, 2, 1 for the cream, which is yellow plus white, and you have 2, 1, 1, 2, 2 representing cyan plus white for the light blue. So this is 2 whites appearing, and you can go ahead and cross that out. Alright, finally we just need to rule out black, or we need to rule out magenta. But this is proving to be a little bit difficult. So we've got this rose here, but nothing else. We've also got this black here, but nothing else. Yep, this is not being very cooperative. But if we keep rolling, we should come to a good answer. Just keeping an eye out for anything that's bright magenta or bright black, or leaning in either direction. We have a dark one here, but nowhere else. So it does sometimes take quite a bit longer if certain parity issues like the one that I mentioned a bit earlier come up in ugly ways. But a large majority of the time you'll end up running into something like this. We've got two blacks. We've got the dark blue appearing twice, so we can finally rule out black. And now we just need to find that magenta wherever it can be, and it's right there. And that solves the module. Alright. So, I have left in the comments, or in the description, a chart of what to add in order to get the 4 colors that identify a color's presence. And on top of that, I just want to leave off with some reminders. The first thing you want to look for are the 4 corners on the 0 grid, the 4 corners on the 2 grid, and if you can't find any of those, you definitely want to look for the O on the 0 grid, the corners of the 1 grid, and the O of the 2 grid. Those are the ones that are going to be helpful for you to sort of rule out colors. But that'll be all. It should be pretty simple to get through a couple of these, but it's gonna take some time to learn all these colors. Some of them are a little close, especially the greens, so you should look out for that. But other than that, it's very straightforward, and I wish you the best of luck in solving this module. Thank you for watching, and goodbye.